Hello, 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 and welcome to our Slush side event about blockchain and IoT. It's so nice to see that so many of you made it here to our offices despite all the construction work and the most mystical shopping center ready next to us. It didn't eat any of you.
Yeah, I think we are missing half of our English-speaking visitors, and they might be still in ready. So that's a shame. But my name is Sanna Frisk. I'm the business manager of Alten IT Business Unit BU6, and here's my colleague.
Yeah, I'm Toni Nylund, Sanna's colleague. We started the BU6 unit together. We've been working on it since this summer, working to develop software development in the Helsinki area.
Yes, great. So here's our agenda for the day. So first you hear a few words from me and my colleague Toni, and then Henry will take the stage, and after here's Henry.
Hello.
And after him is Ricard's turn. And maybe Toni will tell something about our servings and our offerings as an Alten group.
For sure. Alten is traditionally an engineering company. So we offer a lot of services on the mechanical engineering side, electrical engineering, all that good stuff. And now, since for about 10 years now, we've been moving more and more towards IT, and globally IT is now probably the most predominant domain where we work. In Finland, we've been actually working for quite some time, but only on the traditional engineering side of the business. And now since summer, we've been developing IT services also in Finland. So in the northern Finland, we are offering more embedded systems and industrial software development. And here in the Helsinki area, we're really focusing on web development and modern technologies.
So that is why we have this event today. So we are part of Slush as a tech company. And there is one picture where we are located. So perhaps you have never heard about Alten before. That's totally fine, while we only work in a B2B business. So we work together with our clients, and we don't have any own product. So we are a consulting company, and you can see that we are mostly located in Europe. Our home office is in France, and then we have also other offices. So if you're looking for international career, come and talk to us.
For sure.
And then just a few things about the practical things about this office. So we have 2 keys. If you want to go smoking, we need to have a key for the elevator. Otherwise, you cannot come back to the 6th floor. So and the toilets are on the side. It's unisex toilets. So you can everybody can go there, and then we have drinks and food for 85 people. And if you look around you, you might notice that we don't have 85 people at the moment here, so we're gonna grab some people from the street. But otherwise, you can just go to the bar during the event and after the event and enjoy our I don't know, food.
Refreshments.
Yeah, it's really not food, it's just chips. But yes, thank you for so much. Any questions about this office or general?
Okay, and about questions, Henry and Richard will both give a talk, and we'll have a short Q&A session between each talk, so you can also ask questions from Henry and Richard.
Great, thank you. Warm up applause.
Okay, but our first speaker tonight is Henri Laamanen, the development manager of Alten Helsinki. Let's welcome Henri to the stage.
Thank you. Okay, I will speak to you about the IoT today. It will be an intensive presentation in terms of slides, because I'm an engineer by my heart. I've been working in IT industry in various roles more than 15 years. I like still to develop software, and I'm coaching our new team members here. So don't worry about the slides. You can get them after this event if you want to. They are full of information, but you don't have to take any photos or anything like that if you don't want to. About myself, I have a master's degree in telecommunications, and I've been working in project houses, consulting houses, and product houses. So I have I believe, quite good of work experience about different things and what it comes to software development. Okay. Okay, let's start. So, about the IoT, have you heard about it? Is it a familiar term to you? So, good. So no wonder, because it's everywhere nowadays, and it will be even more everywhere in the future. And good thing in it that it's not strictly defined. So everybody can do who are technology savvy. They can develop and produce IoT. But I like definitions. So I took one from Wikipedia. So it's basically if you happen to have anything that can autonomously communicate between another system, and it happen to have unique ID, then you can consider that, hey, that's IoT. It doesn't have to be like in public internet or anything like that. We have a lot of closed networks in industry, for example in factories and so on, where it doesn't make sense to put anything to internet. The history, it starts from the 60s, and surprise, surprise, from the factories and industry. We had, and we still have PLCs, we have distributed systems, and I remember that the concept machine to machine, it was pretty popular, especially during the 20th century. For example, Ericsson was developing a lot of, or investing a lot of to machine programs. And then somebody invented the term Internet for Things in 99, and a few years after that it turned into IoT. So that's about the history and definition. Again, because I'm an engineer, I want to classify things. Everything has to be in strict order and so on. It makes my life easier. This is one possible way to categorize IoT applications. It's not the only way, but today it's my way. And I have listed some of the examples there. I will tell briefly about those to you, and then I have also listed some of the characteristics of IoT systems. Don't take it as only truth. I like to challenge a bit people, so you might disagree, and it's okay. So let's start from the consumer IoT. I guess everybody has, nowadays everybody doesn't have necessarily a television at home, but television is one of the good examples that about the device that is connected nowadays to internet. And recently there were news about televisions that the technique is becoming obsolete and quite old quite fast. So there are these television-specific operating systems, and after all, it's business, so it doesn't make sense for the television producers to update and maintain those operating systems anymore. Then we have lots of sports and health-related applications. Did anybody from Finland or watch Finnish news yesterday? There was a good topic from Kuopio. So small kids in the kindergarten, they are wearing activity wristbands. Okay, there is always problems that the kids may see it somehow like something that forced them to move, and it can like have a negative impact. But in overall, I think that's a good example of how you can apply IoT in practice. And I believe the kindergarten teachers and instructors, they are following the data, and then they can adjust their methods and so on, so that the kids stay healthy and active during the day. Okay, smart home, you can adjust your lighting, for example, and so on. And there are lots of applications related to locating and asset tracking. For example, if you want to go to forest and equip you a dog with a GPS tracker, that's possible nowadays. And some of you may have surveillance cameras at home. I don't record anything. That goes to internet, okay, but you don't know my address, luckily. But they are there just for that the people see that, okay, the cameras are there. I might not want to go there necessarily. Common thing for those devices is that they are normally simple and cheap. So the electric is quite cheap. In terms of engineering, it's not simple, but the overall IoT system is relatively simple compared to, for example, industrial IoT solutions. Normally, they are meant for monitoring, so the devices are sending data to internet, to backend service, or to your mobile phone. And they are most often wireless. For example, Bluetooth is widely being used. And there are no high guarantees of service level and so on. But that's okay, because if you have a problem, and you can maybe always reboot your device or something like that, and maybe the problem goes away, or switch batteries and so on. Then when we go to commercial IoT, that's mainly for private sector. So companies are offering services for you, for consumers, for other companies and so on. A good example is smart retail. Nowadays you can, for example, if you buy fish from grocery store, you can check that from the tag that is the cold chain state okay during the from the production of the fish until to the grocery store. That's a good example. And building automation, for example, this brand new office building, this is full of technology. There are IoT devices here and there and so on. And isn't the air, it's pretty nice and so on, it's nice warm. And then connected cars. Tesla is of course the best example. It has taken so long already now. So, and it's not just about IoT. It's just that the whole car is becoming a software platform. So they are using generic electronics there, and you can add new features, more power, and so on, just with software upgrades. Security companies and surveillance companies, they are using lots of IoT. I have discussed with my neighbor. He's a bit worried. He's a virus researcher, and no wonder, because these companies are nowadays using cheap IoT-capable surveillance cameras, and the software, they don't know actually what the software has eaten. So it might be so that the camera is sending the data stream from a place which contains sensitive information and so on to over internet to the, for example, the producer of the or the company who built the camera, or to some other party. And supply chain and logistics are using heavily IoT. It can be as simple as NFC or RFID tag in the asset, and that's already IoT. Actually, the first applications of IoT were based on usage of RFID. And another good example about the RFID tag usage is clothing industry, and especially Lindström. So they have equipped their professional clothes with tags, and you can monitor usage level of the clothes and how many times they have been washed and so on. So simple and but yet powerful application. The systems in commercial IoT are a bit more complex. you have more elements on the software and on the system level. I will tell on the next slides about those. And that thing mainly makes them more expensive because the things or the sensors there in the things, they are pretty much same that are being used in consumer IoT. There can be some applications where the system is actually controlling the thing. So it can send some commands to the sensor or the device that is attached to the thing and then control it somehow. And so the communication must be two-way, and it depends on the application. Sometimes you use wired data transmission, or sometimes you use wireless. It depends on really on the case and the requirements. Then big topic, smart city. Have you heard about that? Are you familiar with the term? It's a big topic, and it's not very strictly defined either, which is nice. So you can do many smart things under the smart city umbrella. It can be something really high tech, or it can be something that participates people. So for example, Helsinki is collecting lots of data, and that data is open data. It's open for everybody of you. And the people in Helsinki, for example, they can then take part to the city designing and so on, and then tell feedback to the people in guys in Helsinki city who are responsible for arranging the services, that hey, this thing is not working very well, something needs to be done, and so on. Or you can develop your own application or service on top of the open data. That's really nice. And again, there are like many practical applications that makes your citizens' life easier in the city. Enhancements to public transport, people in big buildings, people flows can be made easier. For example, Kone has nice solutions for when you enter to some office building, it recognizes that hey, it's you, and normally you are working in the 7th floor, it orders the elevator automatically and so on. It's based on usage of some tag or your mobile phone. And waste management, and also delivery of letters can be made easier, because normally postmen are collecting the letters from the post boxes periodically, but sometimes the boxes are empty or they are full. It depends on the place really, and same goes for trash bins. Environmental monitoring is a big thing, and for example, a Finnish company Vaisala is producing high-tech and really accurate sensors for monitoring the various weather conditions. For example, here in the Helsinki capital area, you can see that, for example, when you're traveling in metro or bus, that what are the weather conditions and how is the air clean and so on. These kind of things made it, these solutions, they are still quite simple. For example, that waste management thing, the sensors are really cheap and so on, but then the overall chain is a bit longer than in consumer IoT applications. The data must be somewhat reliable. For example, if you want to predict weather conditions, you have to have reliable data. It doesn't make sense to like make predictions based on inaccurate data. And normally these applications are one way, so you are collecting data. You are not controlling anything really. Then industrial IoT, so that's pretty much where everything started. You remember on the previous slide, it started on 60s and so on. So that's mainly run by, or fully run by private sector, because private companies are running the factories and so on. Big topic is predictive maintenance. So if you monitor your assets and the IoT does it automatically, you know that beforehand, before something gets broken and so on. Supply chain and logistics are using IoT heavily. It's a pretty similar than on the commercial side. Process control, you can fine-tune your industrial processes, for example, energy production or in chemical production. You can be sure that what is happening there in the factory is accurate and up to date. Agriculture, that's a good application. The farmer can see in real time that are the conditions on the field good for the plants, and is when he can maybe collect the harvest and so on. And of course, robots are prime example of Internet of Things. We don't have yet autonomous robots, and I think that's good. So they must communicate with their master and so on. Okay, then mission critical IoT. We have military, medical applications and autonomous vehicles. Common for those applications is that you cannot make mistakes there. Everything has to work, and it means that because technology can always fail, it means that you have to have options there, and if option 1 breaks, you have option 2 and so on. So it's everything is duplicated, and that makes it complex and expensive, and they are also super secure. So you cannot take that risk that some hacker enters to the system and causes damage, for example, in hospital. Okay, more classification, but now from a different angle. So this slide full of information, it illustrates that what kind of elements do we have there in the IoT systems, what the system has eaten in order to provide the service for its users. So of course on the left we have the things, so it can be pretty much anything, but the common thing for the things, at least now, is that they are quite dumb actually. So we don't have smart fabric or smart materials that could automatically communicate with some other fabric or some other system. So they have transmitters, sensors or receivers and so on. So there is some small electrical gadget that handles the data communication. Then we have networks. At least here in Finland, the networks are super reliable. We have bandwidth and so on, and it's not too expensive either. So I can skip that pretty quickly. But there are lots of elements involved to networks. Normally, the most interesting thing is the first hop. How you can get the data from thing forward to the system. And it can be Bluetooth, for example, or some other technology. It really depends on the application. Then big thing, edge computing. Have you heard about edge computing or fog computing, or are you familiar with the term? So, okay, it's kind of one illustration of distributed computing. So you don't have to do everything in the core or in the back end. You can already do things in, for example, in your mobile phone. There is a lot of computing capacity nowadays in the phones. So if you want to get quick feedback, or the application doesn't even necessarily send the data even to the cloud system or anything like that, if you are worried about your privacy, for example. So you can do the computing in your phone. And I'm not sure, like, well, you can already do some machine learning or artificial intelligence computing even in your phone. For example, simple pattern recognition and so on. In bigger systems, the edge computing is used for like separating the private and public network. and it may even convert the data or something. For example, in factory, you don't want to expose your sensors from your various machines to public internet. It's closed network, and there in the middle of the networks there is edge or gateway more precisely. Then cloud computing. You don't necessarily use cloud. You can use traditional data center or in-premise servers or anything like that, but cloud makes it just so much easier to deploy and then develop these IoT applications. Mostly the complex and most computing resources requiring calculations are done in the cloud. But there are systems like you can distribute, for example, part of the machine learning and artificial intelligence related computing to edge. Then control. This is optional in simple applications, but there are three important topics there. So first is the device management. In consumer applications, you don't need necessary device management at all. You give the sensor to consumer, and he or she uses her smartphone, and that's it. It doesn't have to be more complex than that. But when you go to big distributed systems where you have hundreds or thousands or even hundreds of thousands of sensors, you want to know where are the sensors, are they okay, is there, for example, enough battery, what software they are running, and so on. Because deprecated software with security leaks is one of the biggest concerns at the moment what comes to IoT security. Yeah, then there are more traditional things like user management and monitoring. So, okay, the sensors are sending data towards the backend, but you want to also monitor the system, that is everything okay? Is my device management working okay? Is the network lag inside acceptable tolerance, and so on. Okay, and then we move towards business value. So you can collect data, and quite many companies are doing that, but the big question is that what you do with the data. And their analytics and machine learning are playing big part in that. And we have quite good tools nowadays for that, so you don't have to, for example, develop your convolutional neural networks on your own. You can just take one of those from the AI toolbox of your cloud platform, and that's it. And once you have analyzed the data, then you can visualize that and report that. For example, in consumer applications, good visualization is a must-have thing. You don't want to see any tables or anything like that. It must be fancy-looking graphs or even like red, green, blue. That is everything okay. Simple traffic lights. And then we enter to business. So you can use the information which is refined from the data produced by the IoT systems for steering your business. You can sell the data. That's I think a big market in the future, but the question is that how you can handle the privacy things and how you can separate what is sensitive data and so on. In smart city context, the open data is already happening luckily now, so it's a really good thing, because city is for people, and if city produces data, then people can access to that data. Happy economy, there have been lots of platforms already for a long time in the markets, and so on. This is the last complex slide. Like I mentioned in the beginning, I'm engineer and software developer by my heart. By the way, is there any software developers in the audience? Okay, good. You might see some familiar terms here. So the lesson of this slide is that the systems are complex. If you build everything by yourself, which is of course good fun, you might need to know something about most of these things. Well, luckily you can buy the device and the connectivity from the shop, so you don't have to, unless you don't want to build your own sensor, for example, you can use what is already commercially available. Then we have well-working networks, which is also a good thing. But there are lots of options for different cases. Ethernet, Wi-Fi, Bluetooth are widely used, so is RFID and NFC. Then there are new comers like Zigbee, LoRa, NB-IoT, and LRP-PAN. So those are meant for IoT applications especially. So if you have a, let's say, sensor that is sending a little data quite seldom, so you don't necessarily, and you have lots of these sensors, you don't want to buy expensive 3G or 4G connection for that. That's where the NB-IoT, for example, comes in the picture. Or you have some older protocols. Well, yeah, I was gonna mention this Modbus, but it's from industry. But this Wirepass is a nice thing. Have you heard about that? Finnish technology, so it builds a mesh network. So you don't have, traditionally you have, like, for example, in this office we have Wi-Fi base stations here and there. But now the sensors and devices can actually communicate with each other. And good example about that is, I'm not sure, can you find one of those toilets, but Lindström has this smart toilet paper or hand paper systems, so it can tell to the cleaner that, hey, this roll is now empty, please renew the roll. And how it works, it actually communicates with other of those boxes, and somewhere there in the building there is gateway, so you don't have to put those gateway into every room because they are quite expensive. So it's mesh networking. Okay. Then for software developers, example how you can develop an IoT application with modern software stack. So Microsoft Azure is here as an example. It could be Amazon or Google or IBM as well. They have plenty of good tools as well. But the idea is that you can use edge devices or IoT devices directly, and you can send the data to Cloud Gateway. In the edge, you can already do some computing if you want to. And then in the cloud, it's mostly stream processing. So you can expect to have a lot of data. So you just process the data streams with the stream processing tools. If you want to do something for the data immediately, you put it into warm patch store and maybe trigger alarm or something immediately. If the data is not interesting, you put it to cold patch storage, which is normally a binary large object storage. So, and you can analyze that data later on with, for example, with machine learning. Then you report the findings and information with fancy UI reporting tools, and eventually forward it somewhere. It can be user interface or other business system. So this is, if you want to try, you can, for example, open your Microsoft Azure account or Google Cloud account and try that for free. It's really easy. Okay, that's about the technology and background, and let's jump into practical examples. So here we have a novel medicine dispenser made in Sweden, and my colleague Richard maybe can open a bit the backgrounds because he has involved to this project a bit. So this is a prime and really awesome example about how we can help people with the tools of IoT.
Yes. So you hear me okay? So maybe I can step over here. You having fun? Yay! Yeah. So as you can see, I'm from Sweden. The first thing I heard when I stepped into this office that, yeah, I can see you're from Sweden. You have colorful clothes. Yeah, that was him. Yeah. Yes. So I would just like to tell a bit about this project because I've been working with it for a while. Anybody here who has ADHD? Yeah, maybe not that many. Any who is a drug addict? No, not that either. Okay. Then this product is probably not for you. So,
And you're trying to make business with this?
yeah. So there was a crazy researcher that stepped into our office from AstraZeneca with a bag of money, and he asked us, okay, I have this bag of money and an idea. Could you help me get some more money? Okay, what do you want to do? I want to build a new dosage device for ADHD medicine and opiates. Opioid is basically what you take when you are a drug addict and you want to get rid of your addiction. So this is the finished product, but the fun thing is that we started just to prove the concept and to go to VCs and get more money. We started with a CD player and a screwdriver just to prove the concept. And what this device is doing is that it's screws out granulates, which is basically powder that is screwed out. So what they do today is that you get a cartridge, like when you go and have penicillin or other medicine, you pop out these, and then they sit at home and try to chop it up, which is kind of hard to get the right dosages. So this product is designed all by Alten, both the housing, the plastics, and we have done the design of the motor. So to be able to push the medicine out, you have a small stepper motor that is screwing it out, basically. And the display, of course, and the connectivity towards cloud. We're using Azure Cloud to communicate with it. And then we have BLE to collect the data. And of course it communicates towards an app also, because one of the important things with this device is also that the doctor can get direct feedback from the patients. Because the process usually looks like this, that, okay, you go to the doctor and say that I need to have more ADHD medicine because I have problems. And then 3 months later you go and the doctor asks, how has the 3 months been? I mean, that's not an easy question. If somebody asks me how my 3 months has been, I have no idea. So basically we have an app when you can also communicate towards the cloud and say, with this dosage, this is how it made me feel. I'm happy, I'm angry, I'm crying, I'm suicidal, a lot of different things you can tag based on the medication. Yeah, I just stepped in, this is not my topic, so.
Yeah, but thank you. Yeah, and then just a prime example that what it actually means that and requires when you start to develop a product like this. It's a medical grade device, so it has a really strict certificates and standards, and like I said, it's exact, and I fully trust Richard.
Yeah, we also have a QMS, quality management systems, in Sweden called 13485, which makes it possible for us to develop medtech devices.
Yeah.
It's kind of the hard thing is not the device itself; it's the documentation behind it. Yeah. Anybody who loves documentation? No.
Good. And I think it's getting better and better. You adding more and more features to this and so on. Yep. Okay. Then another example. So back to industry. So this is from Finland. So Finnish power grid company Fingrid. They are monitoring their power switching stations. So you can see the red balls there in the photo. They are actually sensors. So they are measuring the temperature of that cable holder there, and if it's too low or too high, you can expect to see some problems. And in the Fingrid's network, the consequences are pretty serious if you, for example, lose one switching station, even though they are highly automated systems nowadays. But so on. The funny thing here is that even you have lots of electricity near in the sensors, they are using batteries. So of course the voltage is too high and so on. The sensors have been provided by Finnish company Haltion from Oulu. So, and those are using Bluetooth technology and that wire-pass mesh technology that I mentioned previously. So a really nice system, useful system, and it's running in cloud. And Fingrid is also using these sensors because they are multi-purpose sensors. They can sense magnetic fields, temperature, humidity, and so on. They're using those inside the switching station rooms to, for example, detect water leaks. So the good thing is that, well, the additional value is that you prevent those highly expensive component breaks with the means of predictive maintenance, because you know what is happening in your network, and you don't need to go because the switching stations are pretty far away. You don't drive to there just to make the regular checks that is everything okay, and even go to close to those dangerous power lines. Simple but yet semi-complex solution because of the area where this application is working. So you have to know what you are doing, and the good thing is that you are only monitoring. So and the temperatures are pretty close to normal, so you don't have to doesn't have to have any calibrated sensors and so on. It's pretty simple technology. Okay, then last slide in my presentation. So I have listed 10 topics that I see possible. Those are possibilities and threats for IoT. They are not in any specific order, but let's go those through quickly from 1 to 10. So it's a growing market. It's already a big market. There is lots of money involved there, and it's getting bigger and bigger. It's kind of a hockey stick phenomena. So the market is growing faster than linearly. And like said, those smart city and smart factory or industrial IoT are maybe the biggest drivers at the moment. So the good thing for you, if you want to, for example, enter to the IoT business, maybe establish your own company or so on, there is room. And another thing that is good for the new startup companies is a lack of standardization. It's both good and bad thing. So bad thing is that the technology platforms are pretty fragmented. So like you said, so in the previous slides, there are more than enough technologies, and that wasn't even the complete listing, not near of that. But on the other hand, that keeps open for new innovators, and because this IoT technology is not very highly regulated, so you can reinvent the wheel again and make it better. Evolving technologies, of course, electrics are getting and electric devices are getting cheaper and cheaper all the time. So that of course remove the obstacles from investors. So it's not so expensive thing to buy, for example, IoT solution for your business needs. What is a nice thing is that 3D printing and smart materials. Like I mentioned earlier, this we have smart clothes, but they are not really smart. You have sensors there, but only smart clothing that I know is the bike rider suit from Rukka. So when the rider falls, the fabric goes like hard, and it protects the driver. So it's not IoT, but it's kind of smart reactive fabric that works out kind of autonomically. Nobody doesn't have to guide it, that now protect the driver. And the 3D printing is nice. For example, again, industry example, you can, for example, when you are printing kind of lifting hook. You could include a sensor inside the hook already in the production phase, and you wouldn't need to attach anything outside the hook. So it makes it more simple, and the hook can actually tell to external system that what is my condition, am I expect to crack down soon or something like that. Business. Okay, in the point one I mentioned there's lots of money involved to IoT business, but based on my experience from Finnish market, and I believe this applies elsewhere as well, you must have a good value proposition for the customer. Technology gives all kinds of possibilities, but if you try to sell something for companies, consumers are a different thing, of course, but the consumer market is really challenging as well, but it's easier to enter there. But if you try to sell something for a company, you must be able to tell that how this application or this solution helps your business. It's not anymore enough that you can tell that I can collect lots of data with this and so on, or you might do something nice with, or I have nice visualizers here in the application and so on. It's not enough, unfortunately. Security. This is biggest threat as far as I see, because the technology is getting cheaper and cheaper, and again there is business involved. So like I mentioned in the beginning, this television thing, so companies, they don't have any incentives to keep the old technology anymore maintained and for example provide software updates and so on. Technology is getting so much better so fast that nobody really wants to support all old hardware platforms and so on. It's of course a pity thing, but it opens also doors for hackers and malicious persons that who want to exploit those security weaknesses. Platforms, IoT and cloud platforms, like I mentioned in the Azure example, you can try it. It shortens the time. You don't have to build everything from the scratch by yourselves. So you can get into the set up your own application pretty quickly, and that's actually nice. And buy nice sensors from markets. For example, Suunto has this MoveSense sensor. Have you heard about that? So Google that. It's multi-purpose sensor. I don't have one with me right now, but you can try that pretty quickly, and you can measure temperature, magnetic field, acceleration, and so on. So that's at least used in this Rukkas application for kids, so that can be attached to the clothing of the kid, and it measures the activity and so on. Blockchain, clearly a big opportunity, and Richard will tell next about that. How can it benefit, for example, IoT? Sustainability, I already mentioned in the business and especially in the security side option that world is getting full outdated and deprecated electric devices, and what happens to those hundreds and thousands of old sensors which are not used anymore anywhere. So they are small, but still threat to environment. Regulation. As a consumer, I would like to see some regulation because I'm not super worried about my privacy. Maybe I should, but who knows what kind of data those devices are collecting. In Europe, well, we can always believe that the GDPR saves us. It has done some good things, but still it's not very clear for us that what kind of data is being collected. So at least that kind of regulation we can expect to see in the future. And of course, somebody has to tell to device and system providers that, hey, you must improve the security of your system. Yeah, and the privacy was already mentioned in as part of the regulation. Really good example are those cameras. So if you buy a cheap IoT camera and if you have skills to check that what kind of traffic it's sending outside your network, you might get surprised that it's sending small packets here and then to somewhere that or someone who you don't know. And utilization of data, this is big thing because we have already so much data. And there has been recently discussion in the news and newspapers that how the companies could share the data. But no one is really willing to do that because they are afraid of competition or something like that. But a good example was, for example, from Ponsse, a company that produces these harvesting machines for forest industry. And their machines are actually quite smart already now. And they are, for example, measuring with stretch sensors the forces that are influenced to the arm of the harvesting machine. And for example, the steel producing company could be quite, or they should be actually quite keen to know that what kind of data they are getting from the field. Kind of good example that how the companies could share the data in future. Of course, the smart city umbrella is already doing good work there. Okay. That was a warm-up. And do you have now any questions or should I let the lion free now with the fancy dress? And
Yes.
Okay, thank you.
Give
And
Henry an applaud, I think.
Thank you, and like said, if you want to have these slides, you can get them and maybe take them, look at them afterwards.
So did you have like this advanced click thing, or I have to manually push?
You
You
have
don't
to
have
do
that
it.
in Finland?
You are in Finland. I don't have that
You
fancy
don't have
thing.
it, okay.
Yeah,
Maybe
yeah.
I can import it and sell it here then. It's a good
Yeah,
business.
yeah.
It's a good device. Have you tried it in Finland? As you can change slide with a click. I'm just kidding. Nobody's laughing. So has anybody been to the Slush event today? Yes. Did you see the CoinShare presentation? You did? Fuck. It was good. Yeah. I think her presentation will be better than mine, so just so you know. But we have different angles, so you will at least gain something from this presentation also. What do you know about blockchain? Anybody? You have been quiet for a half an hour. You have to be really want to speak now. What do you think about when I say blockchain? Yes. Yeah, you should go down to Malta. They have two times per year. They have a meetup for all the blockchain millionaires there. It's crazy. Anybody else? What? One coin. Yeah. There's a lot of different coins here. Yes. So basically, what this presentation will be about is to talk a bit about blockchain and how to use it, because one of the misunderstandings that I hear when I'm out speaking to companies and people about blockchain is that it's cryptocurrency. So blockchain is not equal to cryptocurrency. Cryptocurrency was the first use case deployed on a blockchain. Okay.
Okay, you can do it on your own. I don't have to be here.
Yeah, now you can go sit and have a beer. That's okay. So to understand a bit about blockchain, I just want to talk a bit about the internet history. So basically, when the internet arrived, it was used for sharing information. And in my opinion, blockchain is an add-on to the internet that we have today that will be used for sharing data instead. Because today, if you look at the internet, we see a lot of problems with sharing data. Like, for example, it's really hard to detect origins of articles and intellectual property, for example. And also, for a simple thing like me sending a transaction to Henry, it's not possible today. We have to go through a lot of stakeholders that has the responsibility to make sure that this happens in a safe and secure way. So from the beginning, it was kind of centralized, and today it looks like the picture on the what's it for you on the right. It's a bit decentralized, but not fully. We see a lot of providers that is owning these central points in the infrastructure. So basically, most of the infrastructure today is owned by big companies like Amazon, Google, that is building infrastructure hubs for all over the world, and basically all the data is flowing through these points. If I would ask a question to everybody here, what do you think is one of the most valuable commodities in the world? When I say commodities, I mean things like diamonds, I mean gold. Anybody else who see any commodities in the world that are valuable, that people want to protect? Yeah, that's true. So one of the most valuable commodities in the world data has become one of the most valuable. So we see also a huge increase in investment in cybersecurity, because if something is valuable, of course you want to protect it. And we also see a trend shift in the companies that are most powerful in the world. 10 years ago, who was the most powerful companies? Yeah, basically 10 to 15 years ago, the most powerful companies was the oil companies. You had Exxon, you had all these oil companies all over the world. They had super much power over the financial economy and everything. Who is most powerful today? It's the company that is owning the data, right? It's Facebook, it's Alibaba, it's Tencent, it's Google. Anybody know about this company? Yes? What did they do? Yes, no, not quite right. What they did was that they, this is actually founded from a military company, Cambridge Analytica. So the idea was to use, in warfare you use something psychological warfare, it's called. So basically you go into a country and you manipulate the people there into giving power to the ones that you think has the most mandate to support your cause. So they had this as background, and then they started with some elections in Trinidad and Tobago, where they, I think it was the Indian populations. They said, if we target them and manipulate them to not vote, this dictator will get power. So they tried it out there first, and it works successfully. And then they went to England, and they did the same thing for Brexit. They targeted a specific group through Facebook data, and they pushed information, sometimes fake, and sometimes information that they had gathered to manipulate the people. And then, of course, they did the same thing for the US elections. And then one guy said, is this legal to manipulate the whole population? Which it wasn't. So what has changed since then? Not much. Facebook still has the data. It's not as open today. Anybody has worked with software development? I saw some hands. So basically, you can still pull data out of a lot of systems, like for Twitter, for example. You can use REST APIs to pull the data out of Twitter, and then you can use it to do analytics. So Facebook has closed some of their APIs, but there's still companies that has deals with Facebook, and I talked to some people, and it's still possible to pull the data out of Facebook. Yes, and what is happening in the blockchain sphere? We see a lot of things happening on the European level. So I have a bet with one guy in my team in Sweden. Yes, we have a meeting 2025. Was blockchain just a fluke? Is the meeting called? But I'm pretty positive that it's here to stay. So we see a lot of decisions on EU level, opening up old closed solutions for new solutions where you can use blockchain to track and to store data. Yes. So what is blockchain? it's a high availability global structure for storing data. So instead that one company or one person is owning all the data, you have all over the world distributed nodes where all the data is stored in real time. And a node could be a computer, it could be a data center, it could be somebody's phone. But all data is stored in all the nodes and the same data, which makes the data stored there immutable. It makes it transparent. You have a lot of different blockchains, but the ones that I say are real blockchains are the ones that are called permissionless, which is not owned by any company. You also have private blockchains like the ones that IBM have, Hyperledger, for example. But that's not a real blockchain in my opinion. It's just a distributed database. So you have this network where you store information. Same information all over. But it's important to understand that if you want to build an application, you can't have it all on a blockchain because that would not be possible. So you select what kind of parts of the application you want to store on a blockchain. Anybody know any limitations that you usually talk about when you speak about blockchain? That blockchain is not good because of this or that? Okay, I will continue. So the first blockchain that came, this is like Henry said, this is just my saying of it, blockchain 1.0. This is the one that Bitcoin is deployed on. This is called the Bitcoin blockchain. So when a transaction is made, when I'm sending my Bitcoin to somebody else, all of these nodes across the network is verifying the transactions. And that is being done with something that is called proof of work, which is basically GPU power. So all these nodes are fighting to solve the transaction. There's a mathematical code. So all of these nodes are fighting to solve this mathematical challenge at the same time. And the one that solves it first gets a reward. Has anybody here done blockchain mining? It's called mining, yeah? Yes, you're still doing it? No. Basically what has happened is that this mathematical challenge gets harder and harder to solve, which requires more and more GPU power, and which is consuming a lot of energy. Yeah, so basically now the Bitcoin value has gone down, and the energy price, energy required to solve the transaction is higher, which make it pretty much not a good business to do it. And I think anybody here who knows how much energy, yeah, I can do the spoiler. Bitcoin consumes around 1% of the world's energy. So it spontaneously doesn't sound like a good solution, right? Yeah. Yes, so that's the Bitcoin blockchain consumes as much energy per year as was it Netherlands or yeah, Netherlands, yeah. Yes, and then we have blockchain 2.0. A couple of years ago, another blockchain was released with the idea that okay, we should use blockchain not for only currency. We want to build applications on top of it instead. So the feature that they added was something called smart contracts, and the blockchain was called Ethereum. And they also have their own currency called Ether. Anybody has heard about this blockchain before? Yeah. So since that was released, we have seen a lot of applications being built. So we have moved from only talking about currency. Now we're talking about a platform where you can actually deploy applications, software that people can use. But what was discovered was that this this proof of work technology, that when you do transaction, it also required a lot of energy, but it was also too slow to build something that was actually usable. So now we have something called blockchain 3.0, and now we have left this proof of work. So some of the new blockchains that are coming now, they're using something called delegated proof of stake instead. Which is basically, I'm not going to go into detail. We can talk a bit more about it later if you want to. But they're using more of a community engagement to solve and verify these transactions instead. So instead of having GPU power, you put a part of your money at stake to doing these transactions. So there's a couple of nodes that are selected to be verifier, and they put their money in stake when the verification is done. So if you decide to fraud the system, the only thing that you can gain is losing your stake. That is basically how it works. And by doing this instead of having GPU transactions, you can have much faster transaction speeds. Yes, and there's also big players that want to create their own blockchain. Anybody who have heard about Libra? Yes, so this is the Facebook initiative. They want to create their own cryptocurrency. And they're also using proof of stake, but instead of the community electing the members, they have elected them themselves. So I like the idea behind it, but the thing is that if you have 51% of the power of a network, you can fraud the systems. So basically, if Facebook selects like 12 out of these companies, they can collude and they can fraud the system, which makes the idea behind having an open source platform where you put the trust in the platform instead of giving it to organizations or companies kind of not there, which is I don't like a lot. But there's a lot of things about them in the news. So I'm a bit skeptic if they will release their platform or not. Yes, and I also just want to tie a bit of my presentation to Henry's about IoT. Yes, so I have two pictures illustrating communication. Anybody knows what the difference between those two pictures are? What technology change do we see here? Yes, so basically what you see here is the transition that is happening within telecommunication. So on the picture on the left, you see how a 4G mast is working. On the right, you see how 5G is working. So you talk a lot about 5G. 3G to 4G, it was a lot about speed with enabling to have video chats and those kind of features. 4G to 5G, it's a lot about IoT actually, enabling device-to-device communication. So me and a couple of other people in my team, we did a case study to see, okay, IoT is coming. How could blockchain map into this? So here is a basic architecture I just wanted to show you, just to see if you can understand a bit where blockchain will fit in. Yes, in the bottom here, you have the communication layer. So this is done for the automotive industry. So you have your car, you have your sensors, and then you have your telecommunication module that is pushing information to the cloud. And then you add a identity and security layer using blockchain. Because the problem is with IoT, for example, is that imagine that you have self-driving cars, and with current solutions, you could add a regular SIM card and you can just call it a car, and the network would not notice. But if you add so anybody could do that, but if you add a blockchain security layer, all the instances has to be verified by the blockchain to be able to be added. So this is the blockchain part in this network. And then you have the data exchange towards the cloud, event login management, and then you build all the services on top of here. So for Volvo, for example, we have something called in-car delivery, where the delivery guy goes out and leaves the things that you have ordered in the trunk. That's an example of a delivery. You can also have taxi services, robotaxi, and those kind of things in the future. Yes, and then I thought I will talk a bit about the projects I've been working on. I don't know, did I forget to introduce myself? I think I did, right? So, my name is Richard. I've been working with Alten for 6 years. I first started up an office in Norway, and then I've been working 2.5 years as manager within embedded systems, focused on electrified cars. And then 2 years ago, I've been managing the cloud and IT team in Gothenburg, and since May, I'm country manager over Alten in Denmark. So I have a pretty mixed background. And outside of that, I've been working in aerospace. I'm working as sales manager within industrial automation. And I've also been head of HR at a Swedish startup company called Naked. Anybody who has shopped anything from Naked? NA-KD, yeah. Yes, so they're a super fast growing influencer guided brand. And outside of Alten now, I'm also co-founder of a blockchain company called Unbiased, and I'm board member of another one called Septagram. So I thought it could maybe be interesting for you to see how we have used blockchain there in those companies and why we have decided to use it. Yes, to start with, I just wanted to show this graph. I think is pretty interesting. So this shows basically the fastest growing areas where you can use blockchain. So the size of the bubbles is how big potential it is in these areas. And on the x-axis, you have how much is being spent. And what's on the y-axis? I think there's growth potential on the y-axis. So I just wanted to, the first startup I will tell about is about asset management. So it's huge potential. And this company called Septagram is deployed on a blockchain called Telos, which is part of the EOS IO network, which is using delegated proof of stake. And we have had people from Alten also working towards Septagram as blockchain architects, and we have done some basic UX design also for them. So short about Septagram. So this company is founded by two musicians in Sweden. They are producers to a Swedish famous guy called Håkan Hellström. Do anybody know Håkan? That's good. I don't like Håkan, so that's good. So basically, they have been producers for many years, but they have had a hard time to make a living because they don't get much. Even if Håkan is super famous and a super millionaire, they don't get much money from it. The music labels is taking a lot of the cut. So they wanted to create a platform for the musicians and producers so they could get more out of the money instead of all the middlemen that we see today. Yes. So the first thing that they did, that they had a song that they had produced. So they started to go to a music label and asked them, okay, how much do you want to pay for this song? And they got a price. And then they went to a Swedish auction house and asked, okay, can we auction this out to our fans instead? And what they saw then was that they got 5 times more paid by their fans and they would have gone from the music label. And then they decided, okay, we want to build a transparent platform where people can trade with music rights, like digital rights. Music rights, it can be music rights, it could be movie manuscripts, it can be games, anything that is an intellectual property that does not exist in the physical world. So what we've been working on is building a platform for trading with IP rights. You can think of it like a Nasdaq, like a stock market for IP rights. But instead of that, you invest in a company, you invest in music or IP rights instead. It can be art, it can be anything. So basically this is how the architect looks like. We have created a web app where the artist can upload their song. And this web app communicates with all the different stakeholders distributing the music rights papers. And then we have created 2 mobile apps where people can go in and invest. Both one for Android and one for iOS. And where we have used blockchain is for the song and data management. Because a big problem today is if you look at Spotify, for example. Today it's impossible for artists to see how much of the money that Spotify is making comes back to us. I think in the music industry, the turnover today is around $45 billion per year. And I think the ones that is producing the content is actually getting 5 of those. So we see a lot of middleman hands between that is taking cuts that is actually not adding much value. I mean, if I would produce something and sell it with my bare hands, I would expect to get more than, what it is, 10%. So we have used blockchain in this application to track and to be transparent. So anybody can go in and see exactly where their revenue is coming from and how it's distributed. Today it's a bit pale. Yeah, but so we have used it for asset management. And basically it's these things that we don't control in the company. We don't control the data that is there. So anybody can go in and see that we can tamper with the data. It's immutability. Everything that is stored on blockchain is transparent. And the consensus part is the proof of stake. And we use smart contracts to build the trading algorithm. And on Telos, on the USIO that we are using, you build the smart contracts in C++. Has anybody tried to build any smart contracts? A smart contract is basically like a dumb contract, but automated. Yes, and some comparison we did when we selected which blockchain we should use. So we have some competitors like West Music that is using Ethereum. So we looked into that. But they have a limitation with transactions per second, which is only 20. And USIO can do 4,000. And this is also another important thing we looked into. Ethereum is consuming equal to Bolivia. So it's less than the Bitcoin blockchain. But it's, EOSIO is 7,236 times less. So even if Ethereum has a bigger network with developers, we still wanted to go with a more environmental friendly and future proof also, because the ones that have selected Ethereum, they have to switch blockchain, which is kind of messy for the users. Yes, and this is another company where I'm a co-founder of also. We started this company in 2018, and last month we were featured in a Swedish newspaper. So basically what we want to do with this company is fighting fake news. We want to be able to influence, we want to be able to reach out to 1 billion people. That's our goal. We see a lot of problems with fake news in the world. I showed you the use case with Cambridge Analytica, but there's also a lot of problems in India, for example. There people have been killed because of fake news has been spread throughout media. And we also see a lot of trust issues today. It's hard to find information about different kind of topics, and it's also hard to know who should I trust. Who of you in here trusts the government, for example? Yeah? I think we live in a pretty good country. We don't have much corruption. So we have pretty high trust in our government in Finland and Sweden. If you would go to Portugal, for example, and ask them there if they trust their government, I don't think they would say that they trust their government. For example, in India, what they trust most is the newspaper. So basically these thoughts were the idea behind this product. And that's why we created the first product, which is seen on the left here. So basically this is a search engine. Think about Google, for example. It's also a search engine, but Google mainly present links. What we intend to present is unbiased insights. So we scrape all the web, for example, say that you want to know about Donald Trump in the US. Then you can search about Donald Trump, and we try to present unbiased insights. So we're using something called NLP. Have you heard about that? It's a part of AI. It's called natural language processing. So it's the AI that is all analytics that is associated to human text or human speech is called natural language processing. So we have built our own algorithm that analyzes the insight of what the text says. So we run it from this algorithm, and then we present it to people. So we are fighting fake news, but we are not saying what is fake or not. We're just trying to provide a tool for people so they can make their own judgment. What does people think of different stuff? So that is the tool on the right there, a search engine to present insights. And then we have another tool, which is called Unbiased Data Marketplace, which is basically a crowdsourcing tool. Does anybody know anything about AI at all? You know, how is the process working when you build an AI solution, for example? Yeah, there's one guy nodding there at least. So basically the hard thing about AI is not about building the algorithm. The hard thing about AI is to have a really good data set, a clean and good data set. So that is basically the hardest thing today. A lot of companies have data, but they don't know what kind of data they have. It's not structured, and it's definitely not annotated. So this data marketplace we have, it's a tool to annotate data, to tag the data, to make sure that the easiest example is probably from the automotive domain. If you have a picture, and in all the pictures you should tag the cat. So that is annotating. Just tag the cat and just say that in this picture, this is how a cat looks like. And then you run it through the machine learning algorithm and it learns. So this is a crowdsourcing platform for tagging data. And in the bottom of this, we have the same features with NLP and blockchain, storing all that is happening in the system. Because it's also hard for, if I send my data to a customer, to a company in Ukraine, for example, to tag the data, then I have to trust them that they have done a good work, and I have to trust them that they are transparent with me. So this platform, you don't have to trust any company. Everything that's happened here is stored on a blockchain, so you can, any point in time, you can go in and do a revision and see what has happened. And it's also a bit of gamification, so people will get rated, and based on how good you are at tagging, you will get awarded by cryptocurrency. Yes. So this was basically what I wanted to present about blockchain. I tried to keep out of everything with hashing and these kind of things, but we can talk about that also if you want to. Any questions? Yes?
Sorry.
Sure. So you said there is a potential for the blockchain in Europe, although there's so many regulations for the this transactions. If I want to focus, for example, on customer to customer business model, I have a problem with the regulations. So each country has its own art. So how do you see that? How can it spread quickly?
Yeah. That what you're saying is that is a big problem when building products today. That you have a lot of regulations. Even in the music industry, for example, there's a lot of regulations that is making it hard for transparency. For example, we are gathering STIM money. You know what STIM is? You know, if a song is played on a radio, you get a part of that as money. But today we can't see that properly because there's too many layers of regulations that is having this, like for Spotify, for example, they are not having a blockchain. So we don't have a hard time to see everything. And it's also, as you say, all the governments have different regulations. But there's a lot of, to be able to build really good applications, we need to do something about all these regulations also. And the banks have a lot of regulations.
Good point to where you, depending on where you're starting, to first meet all of those regulations there. So not trying to do as Uber, for example, don't really care about the regulations, just go for it. But I think it should be wise to take approach of taking those regulations.
Yeah, I agree. But yeah, as I showed, there's a lot of things happening on EU level that is pushing that, like GDPR, for example. That is one activity that's been done that is pushing people towards that. Maybe you, like for personal data, do you really want to own all the personal data? Maybe you can have a system where your personal data is stored in a blockchain and you will get a key. So instead of asking the company, can you remove my data, you can just say that I don't want them to have let's think about it like this. All the personal data that you have is yours. So you have a key to everything. So you can see exactly which companies that are using personal data. So instead of asking them, like, I don't want you to use my personal data, and then you just remove their public key so they can't access that anymore. So, yeah. Yeah, I think he has a question also.
So how does it actually work for you working in a corporation and setting up these startups? How do you manage it?
It's a lot of hours. Yeah, maybe I could use a part of the ADHD medication sometimes also. It's a lot of work, it is, but it's just important to. I'm more of an advisory role also. So I worked in Naked. I understand, you know, how important it is to have a perfect product. You know, the product has to be really, really good. I mean, if you're gonna use this application, this search engine, you will not care about the blockchain. What you will care about is a really good product, right? So that and a couple of other things, I am just more of an advisor.
Okay, thanks.
But it's a lot of hours anyway.
Any more questions?
You can talk with me. I will be here mingling also. So I think people is thirsty and tired. So let's get them some beer.
Yeah, for sure.
Yeah.
Okay,
Yeah.
so this concludes our official program today. The doors will stay open here until midnight. At this point, we'll say goodbye to our stream followers on YouTube. Thank you for joining us, and I hope you enjoyed the program on the web also.
And I know that here are some people who came to talk to us about the career opportunities here at Alten. So you will find us anywhere here in this common area and we can have a chat. And I would like to have like a common applaud for our speakers. Thank you, Ricard, and thank you, Henry. Great drink.